Hello everyone, my topic is cybersecurity in Industry 4.0. I will try to explain cybersecurity in Industry 4.0. The fourth industrial revolution brings new operational risks for connected smart manufacturers and digital supply networks. As you know, Industry 4.0 is an interconnected NPC-based system. Because of this reason, cyber threats can have huge effects than ever before. With the revolutions, new formations are developed such as cyber-physical systems, next-generation software and hardware, Internet of Things, and more. It can be examined the robots taken over the production. So here is the question for our topic. Along with the convenience of these formations, how much security it will provide these systems? In this point, cybersecurity became an important application for Industry 4.0. Firstly, let's look at the threats for cyber systems. Before we begin this topic, we should understand the cyber physical system in Industry 4.0. Basically, CPS is an engineered system that are built from and depend upon the synergy of computational and physical components. In addition to this, CPS are core element for industrial companies to implement vertical integration and network manufacturing systems, where the different hierarchical levels are able to share information in real time for beyond any traditional manufacturing execution systems are intermediate systems to materialize vertical integration. After the CPS, we are going to explain Internet of Things, which is so important in Industry 4.0 and this security of the Internet of Things. So we shouldn't think that CPS is just a one system. All of these in same words. For example, industrial control system, MES, manufacturing execution system, machine to machine. Let's continue. As you can see, there are relationship between CPS and the IoT. According to ICS industrial control system, attackers commonly follow three steps. The first step is to gain CPS to the control system LAN. Second, they try to understand the communication mechanisms implemented in the system to perform specific attacks to the devices. Finally, they compromise the device. If we can model the specific malicious actions against the system, basically changing system set points, preventing a sensor providing input to the controller, causing a sensor to provide out of bounds input, causing a sensor to repeatedly provide the same false input, sending harmful command signals to the components, sending harmful command signals and falsifying component feedback. So, how can we protect our systems against malicious actions? Basically, there are three steps. Create segments without reconfiguring existing networks, develop unidirectional access mechanisms, reduce loopholes in access rules. So, what does it mean? If we are going to deep, the different organizations recommend network segmentation and segregation in order to minimize the access from one segment to other segments. The main security system recommended in all standards to implement these security strategies firewalls, which control the network traffic in and out every network segment. As you can see, there are segments and there are firewalls between the segments, as you can see, between enterprise zone and the industrial zone. Let's continue. There is a different architecture called that OPC-UA architecture. The application layer, the communication layer, and the transport layer. At the application layer, authentication and authorization are required to allow access only to trusted clients. OPC-UA applications have application instance certificates to implement certificate-based application. Layer security at the communication layer, data and encryption provides confidentially to prevent eavesdropping. Finally, other mechanisms achieve data integrity and transport layer security to prevent data loss. Let's look at sample a firewall technique of temporal filtering. The access rules in the proposed CDN firewall are only enabled when connection is required. This feature, known as temporal filtering, is implemented with OpenFlow. As you can see, when a client requires connection to a server, the transparent firewall stops the packet and stops the packet holder. After that, the packet is dropped if it does not match rules, drops the packet between firewall and controller firewall. A message send firewall controller in order to request instructions on how to deal with the packet. When the firewall controller receives the message, the firewall controller checks the information against overall security rules and adds new match and rules, and sends the new match rules and their instructions to the firewall again. With the corresponding instructions, if the packet is allowed to pass through the transparent firewall, then the firewall controller sends a packet out with the corresponding instructions, so that the firewall forwards with the health packet to the answer. The red arrows depicted in figure represent the three-way handshaking that establish TCP/IP transmission control protocol communication. And if there is no communication for a certain time, let's edit match rules and instructions. Let's look at the cases of cyber attacks. Okay. Okay. Case of cyber attacks. Flame, also known as Skywiper and Flamer, is a modular computer malware discovered in 2012 as a virus that attacks Microsoft Windows operating system, computers in the Middle East. Deco attack in Iranian nuclear plants. Deco Trojan hits Iranian's computer systems. Experts say in a statement to Reuters that Deco, based on Stuxnet, is designed to collect data that will facilitate the launch of future cyber attacks. Stuxnet is intended to disable industrial control systems and may have destroyed some of the centrifuges Iran uses to enrich uranium. Thank you for listening to me.